let's draw the profiles. So again, just like for everything, you have different configurations here. I will use the configuration in centimeters, which means that it is 10 times smaller than the length in plan. You can also use it in millimeters. In that case, it will be 1-to-1 with the plan. But some of our users and I also like to have the profile smaller. So I will use this configuration, and I will show you later. Inside of this configuration, everything is stored, from the scale, from the colors, from the data, from the language, basically everything. So double click on it, the dialog opens, and again you have your familiar icon here for selection. And now, because we defined our topology by arrays and by branches, we can easily just click here for the entire system and tell the software, draw me all the profiles in my network based on array topology or by branch topology. And here you can see the names of the arrays that we defined. And now you can just click on draw and get all of the profiles drawn according to array topology. So here we have just 9 profiles, but it's the same if you have 9 or if you have 900. So it's in Urbano, you can have literally any amount of profiles, and they are drawn very, very quickly. So I will also define row and column spacing between them. I will put them, you can put them in the grid, or you can put them all vertical or all horizontal, or in some kind of matrix. I will put them in 5 rows and 2 columns. I will set spacing between them to be 50. So a little bit larger spacing between them, because later you will see that our profiles will expand when we run hydraulic calculation, because also the piezometric lines will be showing in the profiles as well. So be sure to put a larger spacing in between them. Then maximum dimension for all frames. This means that all the profiles will have the frame of a maximum profile. So the profile with the maximum size, all the profiles will have the same frames. But I like to use frame dimension, which means that each profile will have its own frame dimension. And now we can click on draw. Let's place it here. And that's it. So that's how it's easy to draw all the profiles in Urbano. And you can see the terrain line that came from DTM. We see the center line of the pipe. We didn't set up pipe yet. And also all the data is here. And I will show you that everything, so to the smallest detail, everything can be changed and edited inside of these configurations. And the other way, how you can draw these profiles is by, of course, you can draw it always by arrays or branches, and you can select the entire system or some other selections, or you can go from node to node. This is great selection option. I didn't show you before in the data table, but you can use it also in the data table. Really nice option. You click from node and you can go to any node in any direction. But notice that the software is always searching for the smallest path between 2 points. And also notice the profile. Notice how I am going in plan. Also, these elements are labeled in the profiles as well. So this is a feature that can be turned on or off. I usually turn it off because I find it somehow confusing at sometimes, but also it can be useful to see which elements are which. But now you can see that I'm here in plan, and these same elements are in multiple profiles. So I usually turn this option off. I will show you where. So to turn this simultaneous mark, you can go to settings. We can go to general settings, and here you can search mark. And here it says mark all displayed entities. Turn this off and click OK. And now notice when we go from node to node that we do not have this simultaneous marking by default. Okay, and notice that always the shortest path between 2 points are selected. So if you want to go to your defined path, you can click multiple points on the way. So I will click to this node, and then the software will know that it has to go through that node as well. So all up to this node here. Okay, right mouse button, draw, and let's place it here. I will use just OSNAP with the endpoint and with the extension. So I will put it to be also 50 units above it. So that's it. And now we have one more profile, which is drawn from A11 to H412. Okay, and now I would like to show you how you can edit this profile configuration. So basically, like I said, to the smallest detail, everything can be changed. How to edit the configuration? Right mouse button on it. So you can click on the one that you want to edit. Or if you don't remember which one is applied in the drawing, you can click here on the main branch and click edit configuration. And then the software will ask you, okay, but which one? And then you select on any profile, because in this case, all of them are drawn with the same configuration, but you can even have multiple configurations in the same drawing. So the software is asking, select one of the profiles. I will select this ones. And then the software knows that this is this configuration here. When we talk about profiles in Urbano, this is probably the most complex function. It's not hard to use, but if you check it, basically, like I said, all to the smallest detail can be changed here. So how to know what you want to change? Of course, if you are an experienced user, you will immediately know where to find some data. But if you are a new user, like probably most of you are or will be, you will need some quick selection to select something in the profile that you want to change. And that's why we have this interactive select button. So just click on it and then click on any part of the profile. For example, I would like to change this terrain line. Let's click on it, and the software takes you where this data can be changed. So you see this is a green line. Let's change it to be the color 32, which is brown color. And now you can click OK, and you will close this dialog, and this will be changed. Or you can just click Apply and continue editing while seeing how it looks like. So if you're satisfied, let's now go on. Let's again click to Interactive Select. And let's maybe change this cyan colors of the names and the scale. So let's change this to dark blue color for the name. Okay, again, let's click on Interactive Select. Let's click here. For the prefix of the scale, I will change M to S, and I will change the color from cyan to dark blue. Okay, and let's click Apply, and this is changed to blue color. Also, it's not just for the graphical elements. You can also pick on any numerical or this data in the profile table. You can click on a header, or you can click on the data itself. For example, let's click on this yellow line here. So this is the length slope data, and here you can see slope line color is yellow. Let's change it to black. Okay, and that's how you can basically edit all the parts of the profile. So for example, let's click here on the header, and here you can see that this is a row header, and here you can change anything. Let's click OK. So that's about it for editing of the configurations for now. Day after tomorrow, when we have additional topics, or I like to call it advanced training, I will show you some more advanced stuff about editing of the data tables. And also, I didn't say, but this data that you see here are not fixed. So basically, here you have many data. If you again go to this data picker, any of this data, you can delete it, and you can add some other data. I don't know, maybe some hydraulic data or data about excavation volumes, or I don't know, data about intersections or crossings with some other infrastructure, or basically any data that you might want to have in your profile tables, you can have it. So let's click OK. Okay, so now that we defined the profiles, we drawn the profiles, let's also set the pipes. But before we set the pipes, let's save now this drawing. We have been working more than 1 hour, so I think it's a good time to save it. So let's save it, and I will call it Urbano Hydra working. Okay, so I already explained that the main topological elements of Urbano model is node and section. These nodes and section can have pipes and manholes, or they don't have to have. So to set pipes and manholes to nodes and sections, we have to go to our catalogs. So here is the icon for the catalogs, and here you can see all the different catalogs in Urbano: catalog of pipes, catalog of manholes, catalog of trenches, top layers, protecting pipes, many different catalogs. So let's open catalog of pipes. And here you can see this is the catalog of drawing, this upper part. You will see that when you set some pipes from the application, they will also appear here on the top. Why is that? Because they are then saved in the drawing. Because you can create some of your own pipes, you can apply it to the drawing, and then when you send it to someone, that someone may not have the same catalog as you, but they will have those pipes because they are saved in the drawing. So here you can see all the different types of pipes available in Urbano. So of course we have circular pipes, rectangular pipes, egg-shaped pipes, I don't know, some combination of rectangular pipes with the circular bottom and stuff like that. So of course for each pipe, so these are some egg-shaped pipe. You can see the shape. You can define the material. You can define some user data like manufacturer, description, and of course, all of the geometrical data like sizes, thicknesses of the walls, and so on. So let's check maybe this circular concrete pipes, or let's check maybe circular PEHD pipes, and many different pipes, shapes, sizes, everything is here. And don't treat this catalog as some standard. This is just some pipe catalogs that we defined as a default, but of course that may not be applicable for different countries, different standards, and so on. So if you want to create your own pipe catalog, of course you can edit the existing ones by just changing this data, or you can create your own catalog. And now I will show you how you can create your own catalog of pipes, because this is probably something that all of you will do. So click on Disk Catalog. This icon appears to add a new catalog group. Give it a name. I will call it My Ductile Iron Pipes. Okay. Then choose the type of the pipe. I will use circular pipes. And then click here to add a new item to that catalog. You can add one, and then of course you can define the material, you can define the roughness, you can define all the geometry data, and so on. So this is one way how you can do it. Then you can maybe copy it and just change the geometry values, the diameters, the thicknesses, or the way how I like to do it, I create the amount of pipes that I need. For example, I will create 15 new pipes. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I created 15 new pipes. And now you can click here on the group, right mouse button, and you can go to Edit Group Data. And then this will open just like Excel table with all the data here. And this is, like I said, just like Excel table. So for example, you can type the material. I don't know, ductile iron. Enter, and you are in the second cell. Or you can copy something and paste it. So basically just like you are in Excel. And not just that, you are basically, like I said, just like in Excel. So you can select the entire table, you can copy it. So I will copy it and I will go to Excel because it's much easier to edit something which is in a spreadsheet way in a spreadsheet editor like Excel. So I will open this Excel file and I will just paste this. So you have to paste the template, the empty template. So I created the 15 pipes, and here I have the pipes that I copied from my local manufacturer, because each local manufacturer has the PDFs of their pipes. So you can take it, you can copy the table to Excel, you can edit it a little bit. And now we have to structure the data like Urbano catalog requires it. So you can see these are the names of the pipes. Let's copy this here. Okay, you cannot change this because the pipes will be circular. For the material, let's copy this cell and let's paste it here. Next, we have to have roughness, and here I have roughness. So just be careful to copy the right data to right cells. So this will be roughness for the ductile iron. For the manufacturer, I don't have data, but I can type something. I know that we have here a local manufacturer called MIV, Metalna Industrija Varaždin. So I will just use that manufacturer. You can put some description as well, some standard as well if you want. And then we come to this data about geometry. So nominal diameter, or first I need inner diameter, is here. So let's copy it. Let's paste it here. Nominal diameter is this. Let's copy this. Let's paste it here. Pipe outer diameter and wall thickness. Let's copy this and let's paste it here. There is some other data that you can fill out, but you don't have. For example, some custom data if you want, or I don't know, some other data, but I will leave it empty. And now you can just select like this, the data that you edited. And now I will copy this. Let's go to our table in Urbano. Click to the first cell. So to the first cell where something will be pasted, and click paste. And now the catalog is created. So very easy, very quick to create your own catalogs of pipes. Not just pipes, anything else. And of course, let's apply this. Are you want to save it? Yes, this will be saved. And this is, like I said, catalog of application. This is not just for this project. This is now here for all of your other projects as well. And now you can see, and you can see all this data here is filled out. Okay, let's click OK. And let's go to this Excel table and let's save this. I will save this and I will close the Excel. Okay, so now the pipe catalog is defined. Let's set the pipes. So to set the pipes from pipe catalog, we have to go to function for input data, pipes, or you can start the same function from the ribbon. So I will start the pipes function from the ribbon. And here you can see that you can select a pipe group, all these pipe groups that I showed you in the catalog. So here is also the new group that we created, my ductile iron pipes, but I would like to use PEHD pipes. So I will use this pipe. So these are water PEHD pipes with the nominal pressure 10. Okay, and now we come to those selections that I showed you earlier, which are now becoming to be very, very useful. So we have the selection options. Of course, you can select the entire network and set the same diameter to the whole network. But let's use the selection of branches. And for this main part of a branch of a network, I would like to here define, let's say 315. Let's click save. Okay, Now let's select maybe this branches here, and let's set here a little bit smaller pipe. Let's set 200 millimeters from the catalog. Let's click Save. Notice how the profiles are automatically updating, but the pipes are yellow by default, again, for the black background. We will change this in a minute. So let's now continue. I will select these horizontal branches, and here I will set, let's set 180. Let's click Save. Then continue to these parts here. I will set this with, let's put 140, save. And for the last part of the network, let's set here 110. Of course, we can also size the network and get the optimal pipe diameters, but this is the topic for tomorrow. Tomorrow we will talk about setting water tanks, setting water demands, performing hydraulic calculation, and pipe sizing with pipe diameter optimization. But for now, we have a basic course, basic training, so these are the basic functions. So we define the pipes, so let's go to our plan, and let's also put the diameter data in our label. So for the labels, now I would like to switch the configuration. I will use length and diameter. Double click, select it, the whole network, apply it. And that's easy how to change the configuration of the labels in plan. And also, like I said, I like to mark it as a default so that I know that this configuration is currently applied in the drawing. And you can see that now for each pipe, for each section, we have the pipe set and the known diameter now. Also, if we open our data tables, for example, for the pipes, now I'll just double click on it because I want to quickly check the data. And here you can see that we didn't set the diameter, for example, like in EPANET. We set a pipe from a pipe catalog with all the data defined in the pipe catalog. So now you see this, we define the pipe, and now inside our data tables, we see all the data about this pipe. So the section name, what is the pipe name, pipe material, nominal, inner, outer diameter of the pipe, wall thickness, roughness, pipe volume, all the data that you might want to see in the data tables. And if we check our profiles, you see that the pipe appeared in this yellow color. So let's also change this as well. So let's go to our profile configuration, right mouse button, edit. Let's use interactive select to select the pipe. And let's change all the yellow color. So this is the visible part of the pipe. This is the outside thickness, outside pipe wall. Let's put it to blue. Let's click apply to check it. Okay. And also the inner, this is dashed, but also you can change it not to be dashed, to be continuous as well, but I will leave it like that. And also midline is turned off. The midline is turned off. This, what we see here, is not the midline of a pipe. This is the, as I said, we call it invert, but it can be any point of a pipe, and we define it to be a center line. So let's click apply. And let's also use interactive select to click on this center line here. And here you can see this is the black line for the invert. And now I will explain why I like to use it to be axis. Because now if you see here, we have the changing of the diameters. And I always like in a water system that my pipes are connecting in the axis. And also later on, when we run hydraulic calculation, or when we export this to EPANET, this is the elevation that will be exported to EPANET. So if you want to have it on the top outer or bottom outer or bottom inner, you can define it before drawing here in the system settings, or of course you can edit it later by go to editing and edit invert position. So this is something that it's really important to understand. But I will keep it like this. I like to have it as a center line. Okay, we defined our invert or center line position to be on a constant depth below terrain, 1.5 meter below the terrain. Okay, let's now check if maybe we are somewhere too deep or too shallow below the terrain. To do that kind of analysis, I will go to function on a ribbon for profiles, which is called Draw Auxiliary Elements. Of course, you can also go to Tools for longitudinal sections and find the same option here, Draw Auxiliary Elements for longitudinal section. So what I want to draw is some kind of a helping lines, terrain parallels. So many different helping points or lines can be drawn with this function. So you have to search for the one that you need. Let's check for terrain parallel. And now you can select just some profiles where you want to draw this, but I will select all the profiles. So let's apply it to all profiles. And now first offset line will be 1 meter below terrain. And the second line will be, let's say, 3 meter below the terrain. And now it asks also to draw additional points or not. Yes, always please draw additional points. And now when we click on draw, you see we have this helping polylines, which are basically the terrain parallels. And now we can check it and we can see if we are somewhere too deep or too shallow below the terrain. And when we talk about these additional points, previously I mentioned them, but now when we zoom to profile, you can see what are those additional points. So if we don't set the additional points, basically the line between the two nodes would be straight. So you will have only the elevations in the nodes. But of course, we would like to have these elevations in between as well. So basically, these are the points where these sections in plan are crossing the triangles of the DTM. Of course, if you notice that some points are not surveyed correctly, you can also delete some of those additional points. But it's really important to have them because later on we will also calculate the trenches and the excavation volumes. So it's not the same if this, for example, this line here is straight or if it goes up and down, because the volume calculation that we will run later, you will basically get not the right excavation volumes. Okay, so we can just change some of these positions quickly. I will show you many different options how you can do it. For example, again, we come to our data tables. So let's open again our data tables. So let's switch maybe to section geometry. And let's now use one more selection option, which is really nice. And that is selection of profiles. So let's select this profile here like this. And now we can also maybe go to marking profile and we can go and see, for example, I would like to change this section here. And here you can change starting or ending invert elevation. And in that way, you can modify the pipe elevation. But also there are many different ways how you can edit this. Some of the options are also exposed on the ribbon. You have a function for drawing the pipe position, pipe elevation directly in the profile, inputting or editing, or even if you go here, you have more functions. So interactive invert drawing, input and edit pipe invert. Those are these two. And also you have one more, which is called edit pipe invert in longitudinal section. But the point is that you can check some of this by yourself. Now I will just show you this one. This is the one that I like to use most often. I think it's the best of these three. And basically with all three functions, you can achieve the same results, but in a little bit different way. This function is really nice because it allows you to select the entire profile, or you can go from node to node in profile. For example, let's go in this profile from this node to this node like this. And for example, now I would like to straighten my pipe between these two nodes. Of course, here you can also define what will be your referent pipe point. So if you are not satisfied with axis, so if we click here to preview, you can see here we are seeing the data. So you see depth is 1.5 for the center line. But for example, here you can change it to top outer, and now you can see the data for the top of the pipe. Here you see the depth is now 1.4, 1.4. So even in these functions, you can change this referent point. But like I said, I like to keep it to axis. Okay, so I will just straighten it, but also you can straighten it by line, or you can straighten it by defining the exact slope. So let's set the slope to -5 per miles. You can have the slope in per miles, or you can also change the unit and show it in percent or in ratio as well. Okay, and let's click apply. And now you see that here we have straight pipe between these two nodes. And also be careful when selecting if you have somewhere branching in the network. So if you select, for example, from this node to this node, but here I have the straight piece. For example, if I select from this node to this node and I straighten or edit the pipe elevation like this node here, this branch node here will not change. So be careful about branching nodes. So that's if you use this option, I like to always go from main node to main node. For example, let's again go from this main node to this main node. I will straighten it, but also I will put this point to be a little bit more deeper, because not just with this function that you can straighten it by line or by slope, you can also precisely define starting or ending depth or elevation. So let's set here depth to be 2 meters. Let's click preview. I like how this looks like, so I will click apply. So that's how you can easily change pipe elevations directly in the profile. And notice how your data table are automatically changing. This blue values in the profile means that this is changed. So when something is black, this means it remained the same. And if something changes to blue, this is just temporarily, this means that that value changed. So let's check other profiles as well. Okay, here you can see if you need somewhere to intervene or to change something. Of course, we have also some automatic error detection where you can search for these pipes that are, for example, too low, but I would like to show you this way, this graphical way. For example, here, maybe we can change this as well. So let's again select this part of the profile from this main point to this main point. We will straighten it, and also we will make it a little bit deeper. Let's also go 2 meters below the terrain. Let's preview it and let's apply it. So that's how it's very, very easy to edit your pipe elevations, either using directly functions for editing in profiles or functions from the data table. Okay, let's now close this. Let's again open draw auxiliary lines, and let's delete these helping lines. I will click delete all, and they are gone. Okay, we set the pipes, we defined the pipe elevations. Let's now also set the manholes. So just like for the pipes, you can go to catalog of manholes, and here you can see all the different types of the manholes. Just like for the pipes, you see that you have different types of the manholes. You can click here to info to check what is the type. So you can have this rectangular manholes. You can have also the circular manholes with or without this entering part of the manhole. You can also have I don't know, manholes with the angles, so it looks like a like this object here, or so basically many different shapes, different sizes, different materials. Everything can be set up here in the manhole catalog. You can even define all the thicknesses for the walls. You can define basically everything, all to the smallest detail. So I will not create a new. It's basically the same like for the pipes. You create a new group, you choose the type of the manhole that you would like to create. You have this info to see how the manhole type looks like, and that's how you can create your own manhole catalog. But let's now set the manholes. Again, you can go to input data, you can go to manholes, or you can go to ribbon and go to function for setting of the manhole in the plan. So let's open the function, and here you can again see that you have all the manhole groups from the catalog. Let's use, for example, I would like to use a rectangular simple manhole. Simple means that it's just a rectangular box without that smaller part for the opening. And I will use the size of the manhole 1200 by 1200. So it will be a square, like a box, a manhole. Then you can also put some manhole label in the profile if you want. I will not. Then you can define some even height above the terrain if you need that. You can also define the depth below the pipe. I will set maybe 0.5. And then also you can define the depth calculation option. So for the depth of the manhole, this is really nice. Of course, you can set the absolute elevation for the manhole bottom, but this is not recommended, because if you then change the position of the pipe, the manhole bottom will stay fixed. So that's why it's always recommended to use this first two options. So the bottom of the manhole will always be in relation to the pipe. So to the outside edge of the pipe or to the inside edge of the pipe. I will always go from the outside edge of the pipe 0.5 meter deeper. Also, you can define the bedding thickness. I will reduce it to 20 centimeters, and that's it. You can then select the whole active system. But like I said, in Urbano, not each node has to be a manhole. So that's why I will go to selection of nodes, and I will select just these nodes where we have branching in our system. So I would like to put the manholes to the nodes where we have branching in our network. Of course, you don't have to use manholes. This is not essential for the water system. Of course, for the sewage system, you would like always to use manholes. But for the water system, you are not obligated to use manholes if you don't need them. So let's click Save. And now you will see again the dynamic model of Urbano. Let's zoom to profiles, and everywhere now we have the manholes. You can also redraw the profiles for everything to update. So if you redraw it, you can see that you can choose these pipes to go to the edges of the manhole, or you can inside of the configuration. So like I said, everything can be customized. Inside of the configuration, you can decide if this will go to the manholes or all to the node axis. So now we have the manholes as well.